Hello everyone. Let's see how SQLOS works in this session. Firstly, SQLOS consists of its own schedulers parallel to Windows scheduler, and threads has been started to be called as workers to make them different from Windows threads. You can think about workers as a logical representation of OS threads. There are limited number of workers, which is set by max worker threads configuration in SQL Server. The number of worker threads depends on the number of CPUs you have. These worker threads are evenly distributed among the schedulers. For example, if you have maximum 256 worker threads, each scheduler gets 64 workers. Each time there is a task to execute, it is assigned to idle worker. When there are no idle workers, the scheduler creates a new one. Okay? It also destroys idle workers after 15 minutes of inactivity or in case of memory pressure. Each worker uses 2 MB of RAM in 64-bit SQL Server for the thread stack. Workers do not move between schedulers. Tasks do not move between workers. SQLOS, however, can create child tasks and assign them to different workers, for example, in the case of parallel execution plans. This may explain situations when some schedulers are running on the heavier loads than others. Okay? Let's see how this whole architecture works. For example, client connected to SQL Server and submitted following update query. This update query changes data, does some I/O operation and deletes data. Then this task is submitted to less busy scheduler. Let's say currently the first scheduler is less busy and this task has been submitted there. Let's see now how this task is completed. Each SQLOS scheduler has worker pool, runnable queue, I/O request queue, and waiter list. As we discussed before, CPU core consists of running, ready, and waiting queues. Worker pool has list of available workers. When a task is assigned to this scheduler, task is assigned to one of these workers. Then this worker thread starts doing changing data. For this worker thread is moved to runnable queue. At that timing, the task state becomes runnable. Then this task is moved to CPU and run. While the task is being run in CPU, the task status changes to running. Let's say in the meantime, another task comes and assigned to worker 2. However, this task does not move to CPU until the first worker finishes. Only one worker can run on CPU from corresponding scheduler. Let's now suppose we finish it changing data and it's time for I/O operation. During this time, I/O request is submitted in OS level and this task is moved to I/O request. At that time, the first task state changes to suspended state. While this request waits in suspended state, next worker is submitted to CPU and is run. When I/O request is finished, this first worker is moved to runnable queue and waits its turn on CPU. The same process continues in the next stages. If a worker waits for resources other than I/O like memory, log, latch, this worker is moved to waiter list and the state changes to suspended state. This is a short summary of what we discussed until now. With the exception of initialization and cleanup, a task spends its time switching between running, suspended, and runnable states. The total execution time will include time in running state, when task actually executed, time in runnable state, when task is waiting for CPU to execute, and time in suspended state, when task is waiting for resources. The goal of any performance tuning in SQL Server is reducing task execution time. You can achieve this by reducing the time that query task spends in any of these states. For example, if running time is high, you can reduce running time by query optimization like creating indexes. Or you can upgrade hardware and move to faster CPU. If task is spending a lot of time with runnable state, it means the task is not getting enough CPU time. This means your CPU is busy. you can shrink runnable time by reducing the load on the system. If task is mostly suspended state, you should check for what resource task is waiting for. What resource we are waiting for, right? For example, if it is waiting for I/O, you should check your I/O subsystem performance and try to improve it. This is a great way of narrowing down the scope while performance tuning in SQL Server. Let me show you what I have talked about until now. I have this VM with single socket and with 2 virtual processors. Let's check how SQL Server has built SQLOS on this processor. For this, we check SysDemOS schedulers, where we can see scheduler and CPU level information. You can see those 2 virtual processors, right? And SQL Server created corresponding schedulers for each CPU. You can see that the status of each scheduler, visible online and hidden online, right? Visible online ones are visible schedulers where SQL Server can use for user queries. Hidden schedulers are used to process requests that are internal to database engine, okay? So we are interested more about visible online ones. Number of current tasks that are associated with this scheduler. This is cumulative, okay? This means that after starting SQL Server, each scheduler completed this amount of tasks. This is runnable queue, which we talked about, and as you can see, we don't have tasks in runnable queue yet. This is worker pool, also I/O queue. So here, this is SQLOS architecture, which we talked until now. Let's now switch to task level information. To check task level logs, we use this query. I'm going to share this query, so you can also check, no worries. As you can see, we have only 1 task running currently. This is one select query. Let's now create one blocking and check how it is reflected here. For this, I run this first query where I run update query, but do not commit, It means log is not released. In the meantime, I start another session, and this session you can see is blocked. To check why this task is not finishing, suppose that we don't know what is happening, and to check why this task is not finishing and long running, let's see task level information. Here we can see session ID 66. As you can see, this is the exact query which we are running. Task state is suspended. Oh, it means we are waiting for something, right? The issue started to become a little bit clear. Wait type is LCK, and we are waiting for key resource, since this is locked by session 63. Oh, understood. Our task is not finishing because it is in suspended state, being blocked by another session while accessing this resource. Wait time is huge compared to CPU time. This means mainly we waited instead of running on CPU. This task has been assigned to this scheduler info, In this way, we simply looking at task level information, we can clarify many things while troubleshooting performance issues in SQL Server. Great, isn't it?